Our next presentation is IRP Next Generation Thermodynamic Data Development and Analysis for Nuclear Waste Repository Performance Assessment and Decision Making. Now, we should note that this is a 4-year and $3 million effort. I'm the federal point of contact, and your technical point of contact will be Maverick Zavarin. Next slide, please. In order to assess the safety of a nuclear waste repository, we must predict the eventual migration of its radiologic components into the environment. Numerical modeling of processes affecting the behavior of radionuclides is an integral part of a radiological safety assessment. Basic information necessary for numerical modeling is provided by speciation calculations based on thermodynamic data. Geochemical modeling, dependent on the quality of the thermodynamic data that is used and the nature and scope of the database. Next slide, please. The Nuclear Energy Agency, NEA Thermomechanical Database Project exemplifies methodologies needed to develop a thermodynamic database. The NEA TDB project is a database that contains data for all elements of interest, documents the source data, is internally consistent, and addresses all solids and aqueous species of interest. The NEA TDB effort, however, is aimed principally at radionuclides. It largely excludes natural minerals and several aqueous species. It focuses on thermodynamic data for conditions of 25 degrees centigrade and 1 bar pressure, and it is limited mainly to low temperature pressure salt repositories. Next chart, please. Our objective, high ionic strength solutions, may also be found, and processes relevant to nuclear waste disposal, such as kinetics and sorption, are not considered in the NEA TDB. Surface complexation and ion exchange have not been integrated with any traditional thermodynamic database programs, including NEA TDB. Thermodynamic databases are limited and do not span the range of conditions that may exist in various generic repository scenarios, such as salt and deep borehole. The NEA TDB project alone will not satisfy the needs of the DOE. It was the NEA that identified the need to develop surface complexation ion exchange databases in concert with classical thermodynamic databases for performance assessment. Next chart, please. Work to be performed involves thermodynamic data collection and database development. This includes new approaches to update U.S. databases, integrate U.S. databases with internationally recognized data sets, develop methodologies for quality assessment, uncertainty quantification, and benchmarking, develop international collaborations to compare and benchmark, perform experiments to populate thermodynamic data and/or address issues, address known limitations in data and databases at high ionic strength conditions relevant to salt repositories, and develop approaches to integrate surface complexation and ion exchange processes into traditional databases. Next chart, please. Tasks to be performed. Develop a methodology to enhance and update U.S. databases. Integrate U.S. databases with international efforts. Develop new approaches to uncertainty quantification that can be applicable to performance assessment of U.S. repository scenarios. Identify database limitations and provide new experimental data. Develop methodologies for parameterization of surface complexation, ion exchange, and other processes. And develop a reaction database that integrates retardation processes with traditional databases. Next chart, please. Deliverables consist of a technology assessment report, a progress report providing an assessment of methodologies and a framework for upgrading U.S. performance assessment capabilities, an annual progress report in addition to quarterly reports that will outline key accomplishments and progress to date, and of course a final report submitted 3 months prior to completion of the project, a final report in draft prior to the submittal of the final. And we can take any questions that you may have at this point. I'll turn the phone over to our technical expert.
It's Prasad Nair again. Any questions?
Prasad, are you interested only in data relevant to current repository models, or is there a broader set of isotopes that is of interest?
Yeah, it has to be based on the inventory, really, what we have in PWRs, BWRs, and also some of the DOE waste. So there are important isotopes that we are also working on differently. So it can be a larger set of isotopes. The proposer has some flexibility and latitude towards that.
Is the broader set, can that be found somewhere, or is it something that the PI would have to generate?
No, it's got to be, yeah, our main interest is to see the radionuclides transport from the source and go through the media into multiple situations like a aquifer or anything else. So in that process, we see that many closer to the waste form, it's higher temperatures, and then we have these things. So there is a set of radionuclides with long half-lives, and those are important, actinides and others that may be there. So if you need to be, I don't have off the top the list of radionuclides that are currently needed, but published reports, quite a few of them. So if anybody needs that help, Maverick can probably provide that, or just let us contact us with anything specific you may want to know.
Is it required or strongly encouraged to collaborate with the NEA on this IRP?
Not necessarily, but knowledge of their work, because NEA, the TBD technical database that they are working on, is fairly comprehensive. And what we have tried to do in this solicitation is to look at a few things that they don't exist in that technical database. And eventually we think if we develop something here, it will also feed into the NEA database. One point I'd like to also make is that most of the way these thermodynamic database have been developed way back, Helgeson and others, and you do some experiments and then use technical like Gibbs energy or anything else to characterize its performance. So we are also thinking at this stage to get folks to look at a new generation of how out of the box type of thinking, if there is any new ways to look at it. So it's not just developing the information for specific end products, but also if you want to look at a new conceptual framework, we'd like to see that too.
Is there interest in an analysis of reduced order transport models to inform which radionuclides and natural minerals are of greatest interest understanding repository performance?
Yes. Part of the problem with answering that question is it depends on so many things in the environment. And if you assume an environment and then put the reactions in place, it may be, because we are looking at generic repositories, it may be some variability in that. But yes, if an argument is made, we look at that too.
The same question as the last IRP, Prasad. Are all tasks to be performed or just a subset?
No, I think it's fairly comprehensive, and we like, because the IRP is an integrated program, we would like to see all the tasks addressed.
This next question is one that I can answer. The question is, it was mentioned in the webinar introduction that collaboration with the UK is encouraged. Is this applicable for this IRP?
Yes.
And the answer to that question is, with the information that we have right now, we anticipate that the UK collaboration will only be for Appendix A work scopes, which this falls in Appendix C. So you could collaborate on an FC 4.3 project, which was presented about a half an hour ago, but you would not be able to have the same opportunity for this IRP. Now, please keep in mind that that's information that we have now. That won't be finalized until we release the FOA, hopefully later this week. Prasad, the next question is, the work scope includes the words "and decision-making" at the end of the title. What aspects of this work scope include decision-making analysis work?
Well, that's kind of what I was alluding to. Well, if we have decisions with regard to the performance, at the end of this, we are looking at performance of radionuclides being transported into some arena. So the performance we are looking at maybe a dose rate or something else. So that's kind of where we were driving at it from that point of view.
Are only chemical thermodynamic data of interest, or also transport parameters, and how they might be affected by things like temperature?
Yeah, answer to that is less on the transport as much as the chemical issues with high ionic strength and temperature dependencies. Those are important things for us. What we are also trying to do is give the proposers a little more latitude about how they view which one is important. From our point of view, for repository performance, the temperature dependence on these reactions, chemical reactions, is important, and so that we understand very clearly and we are able to better quantify their reactions in terms of its transport also eventually.
The minerals through which things move also matter. Which of those are of interest?
I can't put my finger on things right now. It's the geologic materials that are there. We do have near field bentonite materials probably around the waste package, so there is some man-introduced minerals, and then the natural field mineralogy that is in crystalline or clay soils or salt conditions. So it's natural minerals mostly, and then in the engineered barrier components of it have things like bentonite and other things in the near field.
Is the development of standardized experimental procedures of interest?
That would be a plus, simply because not only the experiments we do, we have to analyze that data. There is a two-step process that's usually used in these databases. Once you develop some data, you have to analyze it in terms of other factors. And what we are trying to do is think through this is there an ability to better represent consistently how we analyze the information. So the NEA is attempting to do all that too, but we have opened it up for the university program to be able to think through what's the best way to be consistent in data analysis, data development and analysis.